KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Free bus for LKG to 8th standard.
Free, hygienic and nutritious food.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Education Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Now we are going to discuss about mirror equation. In our last class, we discussed focal length of spherical mirrors and then derivation for r is equal to f. At last, we discussed some rules followed by the light rays when incident on a curved surface. For example, if the ray is parallel before incident, after completion of reflection, it will pass through the focus. And next, if a ray is passing through center of curvature, it will retraces the path. And third one is, if a light ray will pass through the focus before incident, after incident means the reflected ray will become parallel to the principal axis, right? So like this, we discussed the three rules which are followed by the light rays regarding the spherical surfaces and in case of plane surfaces also, but there we didn't get this much of terminology. There is some difference between plane surface and spherical surface, but the rules you can also apply to the plane surface along with the laws of reflection. Okay, right. So in this class, the mirror equation. So in our last class itself, we discussed radius of curvature is equal to 2 into focal length. 2 into focal length. Okay, right. Now you see here, if rays emanating from a point, actually meet at another point, after reflection, the point is called image of the first point. So you try to understand here, he is explaining, he is telling about what is image, right? So here, with respect to the object means it may be point object or extended object, right? Suppose if it is point object means generally like a ball, okay? So it is extended object means like a stick. Suppose ourself, human is the example of extended object, okay? That is the difference between point object and extended object. But here, when he is giving this information, he is taking object as a point object. So if the ray is emanating from a point, say here, suppose it is the extended object, but he is talking about point object. Point object means it will be here. So these rays, so whatever the rays are here, these rays will go on like this. It is 1, it is 2, it is 3, like that it will go on, right? It is about extended object, right? If the rays emanating from a point or point object actually meet at another point after reflection, the point is called image of the first point. Suppose if you take extended object, observe carefully the light rays which are going from here after completion of incident. So here, these three light rays are going to incident. After completion of incidence, these three light rays will reflect, okay? So here is one and here is other, right? So So when these three light rays meet at some other point, see here. So here we are getting image of the object, that is A dash B dash. Image of the object, that is A dash B dash. So AB is the object, A dash B dash is the image. So A dash B dash is the image of the first point, like otherwise first extended object AB. Okay, right. If you see carefully here, this is and these three 1, 2, 3 are the incident rays. Next 1, 2, 3 are the reflected rays. I already told you, when a light ray is passing through the center of curvature, after completion of reflection, it will retrace the path. It will retrace the path. Okay, right. Next, here itself we have to understand the picture. Before going to see the picture, here they have given some information, right? That also we will finish. See here. The image is real if the rays actually converge to the point. It is virtual if the rays do not actually meet or appear to diverge. So do not actually meet means appear to diverge from the point when produced backwards. When produced backwards. Okay, right. So this is the situation which may happen either in case of concave mirror or convex mirror, right? So that in the morning, in the last class and before the class, I explained you what is the meaning of actual meeting and what is the meaning of appear to meet. Okay, so obviously we have seen in the last class. So that is the same thing here. In regarding the formation of image, the rays are actually meet means it is real image. So rays are going to actually meet to form an image means it is a real image, right? Suppose if the rays are appear to meet means there it is formation of virtual image. Okay, right. See some other point. An image is thus a point-to-point correspondence. An image is thus a point-to-point correspondence with the object established through reflection. Okay. So here it is the image, it is the object. Size of the image may differ. When compared to the size of the object. But every point of the object is going to illuminate by the light rays. So from there the light rays are coming to incident on a curved surface here. Then after incidenting, all the light rays will goes back. Where all the light rays are going to meet, all the reflected light rays are going to meet, their image will be formed. Okay, right. Try to understand this picture. It is the principal axis. It is the spherical mirror. It is the rough surface. It is the reflected surface. Okay, it is the object AB, extended object. A dash B dash is the image of this object. So these three are the incident light rays and these three are the reflected light rays. Okay, so it is a pole. It is the point where this light ray is going to incident. Okay, and one more thing is, this is the focal length and it is the image distance, it is object distance. So in our last classes I concluded that what is object distance, what is image distance, what is focal length. Object distance is nothing but distance of object from pole. Image distance is nothing but distance of image from pole. Similarly, focal length is nothing but distance of focus from pole. Okay, right. Now if you observe this picture, if you observe this ray diagram, you can observe certain number of triangles, certain pair of triangles. Out of those pair, one of the pair is A dash B dash F and MPF, right? So here this P, this is like so we are considering this curved as a straight line like this. So here we are going to assume a point P, right? That is the small assumption, right? So that's why MPF is like one of the right angle triangle. Okay, so here from two triangles A dash B dash F and MPF. Okay, here you can write it as similar triangles, right? From the properties of triangles, geometrical properties of triangles, you can write it as here B dash A dash by PM. B dash A dash by PM is equal to B dash F by FP, right? I will explain you how I am writing. See this, B dash A dash, so this is divided by PM, this one is equal to B dash F divided by FP, right? Next, R over R, B dash A dash by BA, B dash A dash by BA, right? B dash A dash by BA is equal to B dash F by FP, B dash A dash by BA is equal to B dash F by FP, right? So here, okay, so the difference between the above and below, this one and this one is, in place of PM we have written BA, because PM, so this one it is just, you see, like a straight line. For less amount of curvature, you just see here, if suppose if it is the P, so this much of distance we are neglecting when compared to the curvature. If curvature is small, you can neglect it, right? So this is PM, right? So this one and this one both are equal in magnitude, so that the PM is replaced by BA, so that B dash A dash by BA is equal to B dash F by FP, since PM is equal to AB. It is equation number 1. Next, similar to this process, we are going to consider another pair of triangles, APB and A dash PB dash, A dash PB dash. So it is one triangle ABP, another one is A dash B dash P, this one, right? So from these two, I mean from this pair of triangles, you can write it as here B dash A dash by BA is equal to B dash P by BP, B dash A dash by BA, B dash A dash by BA is equal to B dash P by BP, B dash P by BP, right? So I will show you clearly, just see the light B dash A dash, B dash A dash by BA. See how we are comparing the sides, right? Next, B dash P by BP, distance from T to B, right? It is like equation number 2. So it is equation number 1, it is equation number 2. From equations 1 and 2, you can write it as B dash F by FP. See, it is 1 no. B dash F by FP is equal to B dash P by BP. Why? Because if you see the LHS are equal. So you can equate RHS. So B dash F by FP is equal to B dash P by BP, right? B dash P by BP. Okay. So afterwards from here, see how I am writing. See, in place of B dash F, I am writing B dash P minus FP. See how is it possible? It is B dash F, no? So this B dash F, I am writing B dash P minus FP. I can write now. So in place of this, I am writing this one minus this one, geometrically, right? So regarding the magnitudes of this length. So B dash P minus FP by FP is equal to B dash P by BP. So it is like equation 3. Now, according to the ray diagram and as per sign convention, you can write it as B dash P. B dash A dash means what? No? It is the image. So B dash P gives us image distance, right? You are measuring opposite to the direction of incident ray. Observe carefully. It is the direction of incident ray, but I already told you all the distances should be measured from pole onwards. Okay. So when you are measuring from the pole onwards, here it will be like this. Okay. So it is what from here to here you are measuring means it is opposite to the direction of incident ray, so that it is negative. Okay, so B dash P is equal minus V. Similar to that, FP also is minus F. Similarly, BP is also equal to minus U, right? So when these all the things you are going to substitute here, then it will be minus V plus F by F, minus V plus F by F is equal to minus V by minus U, right? So here minus minus will get cancelled. Okay, so this one you can write like this: V minus F by F, V minus F by F is equal to V by U. Then final step will be 1 by V plus 1 by U. 1 by V plus 1 by U is equal to 1 by F. 1 by V plus 1 by U is equal to 1 by F. It will be mirror equation, right? So the above equation is known as mirror equation. Mirror equation. Okay, right. Now what I am saying is, after completion of this, okay, linear magnification. Linear magnification. Okay, so now just before going to discuss this linear magnification, we derived an expression. We derived an expression for mirror equation. Mirror equation, that is 1 by V plus 1 by U is equal to 1 by F. Next, linear magnification. So you know very well, when you are seeing our image in case of plane mirror, what will happen? If you see your face in case of rear view mirror, what will happen? If you see in your mirror in case of shaving mirror, concave mirror, what will happen? So what is the difference? So we already experienced in our daily life. Okay, suppose if you see your image, if you see your face in plane mirror, you are getting same size of object. If you see your face in plane mirror, you will get the same size. So how much size your head is, how much size your face is, the same size you will get in plane mirror. But if you see the same thing in case of concave mirror, what will happen? If you see in case of convex mirror, what will happen? It also depends on the position of the object. That's why I am not sure about the size of your face in case of concave mirror and convex mirror, because it depends upon the position where you kept your face from the mirror. That is also the important point. That's why I can't say the size, but there is a difference. There is a difference. But if you want to get the same size by using concave mirror, same like plane mirror, also you can get. When you keep your head at the center of curvature from a curved mirror, that is what concave mirror, then you will get the same size object, but it is inverted. Okay, but that's why I am not talking about the sizes. But anyhow, by changing the position of your face in front of spherical mirrors like concave mirror and convex mirror, you will get a different sized face, different sized images, right? But in case of plane mirror, it is not like that. In case of plane mirror, you will get same size of the object. So finally, what I am saying is, in case of optics, in case of plane mirror or spherical mirrors, for us, one of the important task is to get magnified image, to get diminished image. Okay, so our requirement regarding the usage of plane mirror or spherical mirrors is also one of the important purpose is to get required sized image. It may be either magnified, it may be either diminished, it may be the same size. So here itself you are getting the importance of this topic, linear magnification. Okay, right. First you see this linear magnification is, right, the linear magnification, okay, So is defined as, otherwise linear magnification is the ratio of the height of the image to the height of the object. Okay, so it is is, I think it appears like as, but it is. Okay, linear magnification is the ratio of the height of the image to the height of the object. So here height of the image is like h dash, height of the object is like h. Okay, right. So that is the definition of linear magnification. According to the definition, so the notation what we are using to represent magnification is small m, right? So small m is equal to h dash by h, h dash by h, right? Magnification gives us the comparison between image and object in terms of size. Magnification gives us the comparison between image and object in terms of size. Okay, right. You see this picture, here we have concave mirror, we have concave mirror, see this so it is the object. Observe the scenario, I mean how the image is formed in case of concave mirror at this point of time, at this or in this situation. See here, so it is the focus, object kept below the focus, I mean what is that, object is kept between pole and focus, pole and focus. So here it is what A and here B, you just imagine here B, so AB is the object. So the two rays are going, actually one point I want to say here, either here or here, any ray diagram we are taking either 2 or 3 or 4 rays, but actually the rays are not 2, 3, 4, the rays are hundreds, thousands. Okay, for our convenience, just to show the position of the image, we are taking 2 or 3 rays. So please notice that the formation of image not because of 2 or 3 rays or 4 or 5 rays, it is because of thousands of rays. Okay, so that's you have to keep in mind, but for our convenience we are taking 2 or 3 rays, right? See here, so this is the one of the ray and this is another one. So it is the reflected ray, it is the reflected ray, and here it is the reflected ray, right? So these two are the reflected rays. So if you see this side, there is no chance for the formation of image, but if we extend here, it is possible to see the image. It is A dash B dash, it is A dash B dash. Okay, so when you are going to see this, when you are going to see this, that is what formation of image in case of, right, formation of image in case of concave mirror. Here this is the size of the image. Just by seeing that you can say that, just by seeing that, by seeing this you can say that size of the image is greater than the size of the object. Size of the image is greater than the size of the object. Okay, so it is said to be magnified, it is said to be magnified, right? It is said to be magnified. So when the size of the image is greater than the size of the object, the image is said to be magnified. You can see here, here it is convex mirror. So in case of convex mirror, in case of convex mirror, if you observe carefully here, this is the size of the image, right? So it is the size of the object. So if the size of the image is less than the size of the object, it is said to be diminished. So the image is diminished in case of convex mirror. Here the image is said to be magnified, right? So that is the difference between these two ray diagrams. That is, one is because of concave mirror, another one is because of convex mirror. Okay, right. See here, anyone, either this one or this one helps us to find magnification. Okay, right? So see here, from triangles A dash B dash P and ABP, A dash B dash P and AB, this is B, so here you imagine B letter, ABP. So A dash B dash P and ABP, you can write like this. What is that? B dash A dash, B dash A dash by BA, B dash A dash by BA, this is B, it is A, is equal to B dash P by BP, this is B dash P, it is BP, right? So it is B, it is P, okay. So taking these two triangles A dash B dash P and ABP, ABP, we have B dash A dash by BA is equal to B dash P by BP. Next, so that is what my ratio of sides is constant. B dash A dash by BA is equal to B dash P by BP, right? Okay. Now with sign convention, this one will become, suppose see here, it is what B dash A dash is the minus H, minus H dash, that is the size of the image, minus H dash, that is the size of the image, divided by H, okay. So it is, yesterday I told you while explaining about sign convention, I mean in the last class, I told you, in our previous classes I told you regarding the sign convention, upward positive, downward negative, according to Cartesian coordinate system, right? So upward means it is like a positive y-axis and downward means it is like a negative y-axis, right? So upward is positive and downward is negative. So that here it is minus H dash, right? Minus H dash by H, minus H dash by H is equal to, right? It is what B dash A dash, it is what BA, right? So that is equal to B dash P by BP, B dash P by BP. So it will be minus V by minus U, minus V by minus U, right? So it is what image distance, it is what image distance, and it is, right, it is what my image distance, it is what object distance, right? It is object distance, okay. So with the sign convention, this one will become like this, minus H dash by H is equal to minus V by minus U, so that M is equal to H dash by H is equal to minus V by U. But I request you, because here we used either concave mirror or convex mirror, both we used, that's why you just see the last step, then you can get the conclusion, right? You just see the last step, then you will get the conclusion. Don't depend upon these intermediate steps, right? That is what M is equal to H dash by H is equal to minus V by U. So keep in mind, magnification is the ratio of height of the image to the height of the object. Height of the image to the height of the object. Based on this, you can also say that is the ratio of distance of the image to the distance of the object. Distance of the image to the distance of the object. But sign convention is important. This is the situation when the image is formed in case of concave mirror. This is the situation when the image is formed in case of convex mirror, okay, right. So in this class we discussed the derivation of mirror equation, that is 1 by F is equal to 1 by U plus 1 by V. Similarly, we derived an expression for magnification of an object, that is M is equal to H dash by H is equal to minus V by U. So we are writing magnification in terms of size of the image and size of the object, then distance of the image to the distance of the object, okay. We will continue in the next class.